Hello, I'm Professor Stephen Abbott. My free ebook, Surfactant Science Principles and Practice, is linked to a large series of apps on my Practical Surfactants website. In this video, we use the apps to see why the stuff we are all taught about surfactants, such as CMC and HLB, are at best unhelpful and at worst plain wrong. My experience, and the experience of many others, is that what is taught on most surfactant courses is actually rather useless, or just plain wrong. They don't, for example, tell you the difference between a type 1, type 2 and type 3 emulsion in a clear way, but using apps we can see what a type 1, type 2 and a type 3 emulsion is. But instead they will almost certainly tell you that HLB is a really important number. Now actually HLB is useless for a fundamental reason. HLB is hydrophilic lipophilic balance, and yet it is ascribed to a surfactant. This surfactant has an HLB of 10. But surfactancy is a balance between the water phase of the surfactant, saltiness, oiliness and temperature. So a surfactant which gives you a balanced formulation at one temperature or oiliness, so the HLB is, let's say, correct, will be useless at another temperature or with a different oil. So you cannot get a hydrophilic lipophilic balance from a surfactant. That is why HLB is wrong. It's really only useful for the ethoxylates at room temperature. Those who are more sophisticated might know about CPP, critical packing parameter. And you get some lovely diagrams, and I'll just show you the app. Critical packing parameter is the tail volume divided by the head area times the tail length. And the idea is that as you change any of these parameters, here's the head, here's the tail, here's the volume of the tail, then the different phases change between inverted micelles, cubic and all that sort of stuff. This is partially correct for relatively high concentrations of pure surfactants. But if you're formulating, you're not generally dealing with pure surfactants in water, you're dealing with complicated things. So critical packing parameter is useless for formulating. And surprisingly, CMC is largely irrelevant. When we go to the CMC app, we see the classic curve where we've got the surface tension as you add surfactant to pure water. And something really exciting and dramatic happens here. You hit a plateau, and that's the CMC. Well, two things. First of all, almost none of us are interested in surfactants in pure water. We have salts, we have oils, we have all sorts of things, so this actual plot is irrelevant. And the other thing is that if you look at it in linear mode, so the plots are normally log mode, if you look at it in linear mode, well, where's the excitement? Most of the excitement is taking place near the start of the curve, and almost nothing happens near the CMC. So the problem with the classic ideas of CMC is that it focuses on this so-called exciting thing and misses out all the interesting stuff, which we'll discuss in a later video. So just imagine CMC curves like this. All the excitement is well away from the CMC itself. So we've described the things which are wrong or not very helpful. In the next video, we'll be more positive to see what we can do about it.